side of the window with the stick pin if you don't have it docked already. We'll look in this All WPF Controls section for the wrap panel. Drag that over, size it as needed, add a few letterbox items. And as you see, they're moving down to the next row. It would make a more interesting demonstration if I changed the letter property, but I think you understand how it works. So then again, to reiterate what the purpose of the wrap panel is to try to get as many controls on the page as possible, and when they won't fit on a row, to automatically move them to a new row or a new column. The dock panel is optimized for docking child elements to the specified side. You can specify top, right, bottom, or left. And you do that using an attached property called dock. If you dock to the top and bottom, then the elements are sized to the full width of the dock panel, and they're sized to the minimum necessary height. Now, this is not exactly true. They're not sized to the full width because you also have to take into consideration the previous docked elements and where they're arranged on the screen. When you dock to the left and right, then it's sized to the full height of the dock panel with the same caveat and sized to the minimum necessary width. There's another useful property, which is not an attached property. This is called last child fill. This indicates whether the last element in the dock panel fills the remaining space. Final rule, children do not overlap. Here's my dock panel. I have 5 letter boxes in there. Since none of these are specifying which side to dock to, it uses the default, which is to dock them all to the left side of the screen. At this point, it looks like a stack panel that's got orientation set to horizontal. To move this letterbox A to the top of the dock panel, I'll use an attached property. Attached properties are this special property syntax in WPF where you specify a property that's defined in one element, in this case the dock panel, but you use it inside another element, in this case the letterbox. So I'll go to the letterbox element, type in the word dock panel. That's the name of the class that has this property. Then choose dot and then dock. It's attached. You see how it's attached to the letterbox? And the letterbox doesn't actually do anything with this. When it comes time to do the actual layout, the letterbox doesn't use this information at all. But the dock panel, as it's looking at each of its children, looks to see if any of the children has the dock panel dock property set. And if so, then it uses that to determine where to put this element. Now let's look at the sizing. You see how this letterbox A is sized to the full width of the dock panel and the minimum necessary height to show the contents. All the other elements are positioned below the A letterbox and they're all docked to the left. Let's cut this and instead I'll put it here on letterbox B. And you see how that's different? So this letterbox here was docked first to the left side of the screen, so that took up the full height. Then letterbox B was docked to the top, and since letterbox A was already docked, it starts at the edge of the letterbox and fills up the remaining space. Next, I'll put D over here on the right side, not C, but D. And then I'll put C on the bottom. That's the 4 basic positions: left, top, right, and bottom. And you see how it's working. It's based on the order that they're in the dock panel. So this was docked first, then B, then D, so it takes up the smaller space, and then C was docked here, so it's not taking up all the space available because D and A are already in position. And then E is set to take up the leftover space, and I'll talk more about that in just 1 minute. What I really would like to have is A and D be the same height and B and C be the same width. So what I need to do is make sure that I change the order. So D needs to dock second after A. To do that, I'll grab this element and move it up here right below A. So now these two are the same height, and then B and C are the same width because they were docked one after the other. Now finally, let's take a look at this letterbox here. At the moment, it's set to dock to the left. That's the default. And it's also set to a property on the dock panel called last child fill. That's set to true. So that means that this letterbox takes up the entire leftover space. Even if I were to dock this to the top, we don't see any results because of that last child fill property. Now, let's say I do want this to dock right below B and I don't want it to fill up the remainder space. I would go up to the dock panel, set this property last child fill equal to false. Now it moves up to just the minimum required height. Use the uniform grid when you have a number of controls that you want to put in a grid layout and you want all of the controls to be in the same width and the same height. Just do that by dividing the region into columns and rows. Then each grid cell is exactly the same size as its neighbors. That's why it's called the uniform grid. The uniform refers to the size of the cells. Each child element inside the uniform grid is placed within its own cell. So the first item in the uniform grid goes in the first cell, and the third item in the grid goes in the third cell. Children cannot overlap each other. You specify the number of rows and number of columns with the rows and columns property. And you can also skip cells at the start of the grid by saying this first column property. I'll show you what I mean. Here's my uniform grid. It defaults to 3 rows and 3 columns, so that's what I'm seeing here. I have 7 items. I have 2 blanks left at the end of this grid. Let's change the number of rows. I'll change it to rows 1, columns 1. That means that my uniform grid is the same width and height as my window, so all of the items in the uniform grid are the same width and height as the uniform grid or the window. And you see that what that means is that only one will show up in the boundaries of the window, and the rest of them are off the screen. Doesn't matter what size I make the window, I can't see any of the children elements other than letterbox A because of the number of rows and columns that I have. This is not typically the way you want to make your UI. You typically want to see them all on the screen. So I'll change this to a different number. I'll make 3 rows, 2 columns. I have 7 letterboxes, so you can see that one of them is still off the edge of the screen. Now I have 3 rows and 4 columns. They're all fitting, and I've got some leftover space in here for other items. That means if I add another letterbox, it automatically gets placed at the end. Next, we'll look at the first column property. When you set first column to 0, that means that the letterbox A starts in the first cell. When I set this to 1, letterbox A moves to the second cell, and you see how everything moved over into their new position. I can keep doing this number until I get to the number 4. When I get to the number 4, it defaults back to putting everything in the original location. So the idea here is first column has to be less than the number specified in the columns. The higher column number here, the higher this first column number can be. I use this uniform grid in certain situations in my applications. It's a simpler grid than the one I'll show in the next video, which is the standard grid. This one, as I said, does uniform sizes. The grid panel gives you much more control over the size of the columns and the size of the rows. Plus, you can start overlapping controls and you can stretch your elements over multiple rows or multiple columns. The grid is one of the most powerful layout panels that we have in WPF. It's very flexible and it can be complex. You'll find that it's the default element that you find when you create a new window or a new page in WPF. And it's typically the root of all the other elements that you use. So you might start with a grid and create 3 columns and 2 rows, and then in one of those columns you might put a stack panel, and in another one of the columns you might put a dock panel. So you use it as a basis of your general UI. It is important to note that this is not a data grid, but it's a layout grid. You indicate how many rows and columns you want, and then you specify the size of those rows and columns. Once you have your layout defined, then each UI element that's inside the grid should specify what row and column to be placed. And then it also specifies whether or not to span over multiple rows or multiple columns. This is the first layout panel that we've looked at in this chapter that allows its children to overlap. So each cell can contain many children, and then children can overlap inside that cell, and they can also overlap across cells. Here's my grid. You see I have a number of letterboxes in there, and you'll see that E is the only one that we can see. If I comment out these 4 lines, Control K, Control C, you'll see that the letterbox A shows up. So the first letterbox was placed in there, and since there's only 1 row and 1 column at the moment, it's put in at full size. It stretches to fill the space inside the grid. Then letterbox B was placed at exactly the same location and the same size, but it's 1 higher in what's called the Z index, or Z order, some people call it. And so it's closer to the user, and so it obscured letterbox A. Here's how you define some rows. Go to the grid, use this syntax, grid row definitions, using the period there. This is called a property element. And then inside the grid.definitions, I define something called a row definition. And then I'll copy this and paste it in so that I have 4 rows. Now, I haven't specified sizes yet. I'll talk about that in the next video, how sizes work. So that means that all these rows are the same height as the other rows. Next, I'll define some columns. And I'm done. So I have 4 rows and 3 columns. And currently, I've only got the 1 letterbox in there. So let's uncomment these letterboxes, Control K, Control U, and then I'll start moving them. By default, letterbox A, and all of these are in the first cell. They're in row 0, column 0. So if you wanted to specify that exactly, you use an attach property. This time it's a property of the grid class. So it's grid dot row. So A is now moved down to this position. And I'll move B over here. So that would be down 1 and over 2. Make this a little bit wider so you can see that. So that's the way I like to think of it. Count down from cell 0. Down 1 over 2. So if you wanted to go here, it'd be down 3 over 2. Let's take and put letterbox C here in this cell. So that'd be down 4 over 1. And then I'm going to use the column span property. I want the D letterbox to start in this cell, but I want it to occupy all the room in this cell plus the cell next to it. Use the column span property for that. And the number here is the number of columns that you want to span. And then finally, I'll put this item, letterbox E, I'll put it here next to B, so it's down 1 over 1. I'm using a trick of Visual Studio here. Instead of typing grid.rowspan, I just typed the word rowspan, or part of it, rowsp, and the IntelliSense engine, the autocomplete engine, found rowspan as one of my choices, even though I didn't start typing grid. And then I can press the tab key now, or double click on this with my mouse. I'll press tab. I specified row span equal to 3, and here you can see the overlap happening. It started here, went down 2, and you notice how it's covering up letterbox, what is that, letterbox D down there? This is the higher in the Z index. Remember this is the one drawn closest to the bottom because it's the first one in the grid, and this is the one closest to the user. So if I wanted D to appear above E and still overlap but appear above it, then I would need to change the order here in the grid. So we'll copy D, or cut D I should say, move it down here. And now it appears to be layered over top of the E letterbox. In the next video, I'll take a look at how to specify the sizes for these columns and the rows. Right now, they're all a uniform size, so really this is not that much different than the uniform grid, except that I can overlap elements and I can move them around and position them in different cells and overlap. I can use the row span and the column span. The other thing I can do with the grid is I can start specifying how these columns are sizes. Right now, they're proportional sized. Well, let's see how to do fixed size and some other sizes. You have control over the size of your rows and the size of the columns in the grid. Here's my example. I'm working with this grid. It has 3 rows defined, and it has 3 columns defined. To set the row size, you use what's called the height property, and to set the column size, use the width property. Now, everything I'm showing you will be in the columns, but all the principles I'm talking about will also apply to row definitions. Right now, I haven't specified any width for the column definition, so I'm using the default, which is called star size or proportional sizing. And that means that each of the 3 columns is in proportion to the other 2 columns. They're all the same width. I can control over the width property by typing in a new value here. And I'll start by showing what's called the fixed size. So I'll type in 60, and that's pixels. And so this is 60 pixels wide. And you'll notice that all 3 elements that are in column 0 are now 60 pixels wide. And you can see, if you look, that it's cutting off the edge of the circle here in all of these. You also see, when I hover over these, there's a blue rectangle that pops up. That's the size that the letterbox would like to be. That's its desired size. And since it's in a column that is narrower than its desired size, it gets truncated. The edge gets cut off. It's rare to use fixed widths in WPF. You want to have a more flexible layout, so we typically use other sizes. Next, I'll look at auto. So I'll type in the word auto here. So now what happens? So you see the desired size for the letterboxes? That was a little bit wider, so the control, in this case the letterbox, asked to be a certain width. And because I set the column to auto, WPF sized the first column to fit all of the controls. Now watch what happens if I change the size of this C letterbox here. So I'll come down here and I'll specify a width property, 240 pixels. So I specified 240 for this letterbox, so that's its desired size now. And so when it was going through the negotiation with the grid, this letterbox said it wanted to be, whatever its default size is, around 120 pixels. This one said it wanted to be the same size. Letterbox C said it wanted to be 240, so that's the largest one. So the grid set to the column width at the largest size. And because all the other elements are set to auto size themselves, they fill up the inside of their cell. Of course, I can always override. I can make the letterbox A smaller or larger by setting its own width property. So my first column is 240 pixels wide, and these last 2 are at the default, which is called the star size. So the way you set star size is by coming up here to the width property and specifying 1 and then the asterisk. So this is the default value, 1 star. And it's called proportional. That's a better way of thinking about it. So we know that this first column is 240 pixels wide. And currently, the width of my window is 525. So let's make that an even number. I'll make this 600. And I'll make this 200. I'll make the math easier. So the way this works is the first column is going to be 200 pixels wide because of this value here. That leaves 400 pixels left over. So you take these 2 columns. This one wants 1 star size, and this one wants 1 star size. So you take that, add those 2 together, you get 2. You divide that into 400, which is the number of pixels that we have in this area, and that means each one of them is 200 pixels wide. They're back to being all the same size. Now, if I make this one 3 star and this one 1 star, now that means that this column will take up 3 times the size of this one. They're dividing up the remainder of what's left over after the 200 pixels here. If you want to think in percentages, like you want it to be 50% of the leftover space or 60%, one way you can do that is type in 60 star and then make this one 40 star, and those add up to 100. So this is 60%, and this is 40% of the leftover width. Now, if I switch this one from auto let's remove the width property here in this letterbox. And then go to this top column definition, and we'll set this one to 20 star. Now my 100% metaphor doesn't work anymore. This is 20 plus 60 plus 40, that's 120. So I might want to change one of these other numbers. That's 20%. This is 60%, and let's make this 20%. This is only a convenience for you if you like to think in percentages. If you just want to look at the ratio and go, well, this should be 1 unit, and this should be 5 units, and this should be 1 unit. They don't have to add up to 100. That's just something I use. I talk to people that are designing. If they like to think in percentages, that's the way you can do it. The disadvantage of this is, as you saw, when I had 60 and 40, they added up to 100. And then when I added 20, they no longer added 100. So I had to start adjusting my thinking. Let's go back and see what we have now. This one, A, B, and C are the same width as G, and then D, E, and F take up 5 star worth of space. As I mentioned, row definitions are exactly the same, except instead of setting the width, you would set the size. So we'll grab this, come up here, and do a height equal 1 star. Copy that. Make sure I get my quotes in there. All right, so there you go. So now this is 5 times the height, and this is 1 unit. So you get a big center unit and narrow items are on this side. If you look at this, it looks a lot like the dock panel and the way it arranges items on the sides of the screen. If you were paying attention, you probably noticed that there were some numbers at the top here. It says 1 star and 5 star and 1 star. These are some designer tools that Visual Studio uses to help us visualize the grid, and that's what I'm going to talk about in the next video. When you work with the grid inside the Visual Studio Editor, you have 2 basic views of it. You have the XAML view and you have the designer view. This, of course, is the XAML view. You can see it over here. It's got a beginning grid tag and an ending grid tag. And when I select one of the tags, you see that there's a gray highlight that shows up. And also, if I select the grid here, you'll notice that in the designer portion of the window, there's some indicators that I've selected. There's a blue outline, and there's some little squares on the left, right, and top and bottom. Those are the sizing handles. In my example, I've got 2 grids. I've got an outer grid and an inner grid. This inner grid is easier to see the outline selectors because I've set the margin to 90 pixels. That adds a 90 pixel buffer around the edges of the grid. And so when I select it, it's easier for us to see exactly what Visual Studio has for this grid. Now you'll notice that when I select it here, it also selects it in the designer. Select it in the XAML editor, it selects it in the designer. And the opposite is also true. If I move my mouse into the designer like this and move into that inner grid, I get a blue rectangle. And now when I click, I'll select that item. It's selected over here in the XAML editor, and I see the same selection indicators, margin indicators, and all the other widgets that show up in Visual Studio. Now, to be fair, this also happens for any other control, like a button or a text box. When you select it in the designer, it also selects it in the XAML editor. But I want to talk about some of the extra features you get with the grid that you don't get with some of the other controls. One of those is this dotted line that's on the left side of the screen and on the top of the screen next to the grid. This is called the grid rail. And this is how you add columns and rows and how you manipulate the existing columns and rows in a grid. So the way it works is you move your tip of your mouse over the grid rail. Now you see that there's an orange triangle up here, and there's also a vertical orange line. When I move over to the left grid rail, I get another orange triangle. This time I get a horizontal line. And this is indicating the location of the new row. So I'll click here. And what you see is it goes from being orange to being blue. And also over here, I see that I've added